So in that case, what will happen is, if we draw like your decision boundary, and then of course we'll have the margins. So this is like the starting point for your support vector machines, and these are your support vectors. So this was like a cleaner case when your classes were clearly like separable. And if you have to train like your support vector, max margin classifier, you will get something like this, where this will be the decision boundary, which is represented by this equation here. Okay, you need like two different parameters. And the margins will perfectly touch like these extreme points. For example, this red dot here and green dot here. And the condition is none of the samples from either of these two classes should actually be inside these margins. Okay, so that was the condition, and that's possible when you have a cleaner scenario. But if it's a non-separable case, then what we can do is we can actually allow some of these samples to cross these boundaries. Okay, so what we do, we not just allow like these samples to cross the support vectors, but we also allow to cross the decision boundary itself. So in this case, you can see that you have a red dot over here, which is lying completely like towards the green dots. So in case of max margin classifier, I mean, you will not be able to come up with a solution because you cannot draw like a linear line separating these two. So, but in this case, if you allow this kind of error, then what will happen is, even if your samples are non-separable, you will be able to come up with a decision boundary. And then what's happening here is, for some of these samples, you will compute like this error term. Okay, so for example, if this is your support vector, then you will compute like the distance between this support vector with this sample which is actually crossing the boundary. So in this case, you will see like three different red dots are actually crossing the boundary. The first two are crossing the support vector. So you have like this eta1 and eta2 as error. And this red one is actually even crossing the decision boundary and also crossing the other support vector. So you have like a very big error here, which is eta5. And similarly, you have errors for like some of the green samples here. Okay, so this is crossing the support vector. That's some error. And again, this one is again crossing the decision boundary. So you have a bigger error. And what you do is, then you try to sum up all these errors. All right, so that's kind of error you will have in your training samples. And then you have like some kind of constraint. You say that you will have some kind of total budget, and whatever error you have from these samples, that should not be greater than this constant. Okay, so that's kind of your allowable error. And with that constraint, you can actually find this equation, and then again your support vectors depending upon what your margin is. Of course, like all that optimization is not going to change. The only constraint you have is this new one, which will compute what kind of error you have for each of these samples. All right.